Okay, so basically I'm going to be doing this past paper, so just a couple pages of this past paper. So basically this is not the complete past paper, right? So basically the paper have about 17 pages, as you can see up here, about 17 pages, but we may not have time for the 17, but either way, we'll just look at how some of the questions are, and basically we're just going to be answering some of them. So yes, so basically we're going to do that right now, and also you can go ahead and look at the different crash courses. So basically here, the first thing, it's very important to read the instructions, very important. So it says that the paper has 6 questions in 2 different sections, answer all questions, and yeah, right? So remember to draw a line through your original answer, but always read the instructions. Okay, so this is now section A. So section A of the paper is showing a molar tooth, right? So as I said before, it's very important to read the instructions. Always read the instructions, right? So basically the labels kind of get shuffled here, but don't mind that. So basically this is the structure of a molar tooth, and what we do is we actually put a photo here. So basically this literally shows you the different parts of the molar tooth labeled. So basically this tooth should be in your textbook. So basically they probably might ask about it, but basically if you never see this before, now you have to see how it look. So they can see all that up here, so make up the crown, that's what's above the gum, and then all of this down here, so it's basically the root and then the different parts in it. So we have enamel and then we have the dentin. So now let's go up here and look back on the photo, right? Let's look back on the photo. So basically it's pointing right here, so it means the first like layer inside, that is where it's pointing. So it says label structure B. So now let's take a look again at this, right? So if we look at structure B, what this is going to be is going to be the enamel, right? The enamel, right? So that's what is going to be. This part right here is going to be the enamel. So go back up and you see how it looks. So it's going to be the enamel, and the function would be to protect the dentin and the pulp, which is underneath it, right? So that is the purpose of the enamel, to protect the inner structures, right? So you can look at the diagram, the enamel, the dentin, the pulp, the gum, everything that's in the tooth. You can look at this and see the different parts. So now you know what the structure does. So basically them actually they're right here, so we cannot move them at this moment. Them supposed to be up here, so but them obviously get shuffled, that's why them are down here. So now the next question is saying what does it say? It says in figure 1 the label A represents a cavity. State 2 factors that are necessary for tooth decay. So basically tooth decay, so what would happen is it's probably poor oral hygiene. So basically not brushing, not flossing, and then also you eating too much sugary food, which would lead to plaque buildup. So basically plaque is just a mixture of different bacteria, food, and saliva just mixed together, and it basically gets stuck in your teeth and can cause a cavity, right? So basically that's the answer to point 2 here. And then it says number 3 point here says state 2 measures other than changing the diet that would reduce the formation of cavities, right? So obviously if you did change your diet and stop eating sugary food and all that, that would help, right? But what else? So basically you can brush with fluoride toothpaste, which I think all toothpaste have fluoride. If you think most, if not all of them have fluoride in there. And also try rinsing your mouth after eating. So for example, you eat something, you don't want to like it gets stuck in your teeth or whatever. You have to be rinsing your mouth to get rid of that excess food, and obviously flossing does help too, and using fluoride toothpaste specifically, so that definitely helps. So then again, this is the diagram of the molar tooth. You probably should know how this look in case they probably ask something about the teeth. You should know. Alright, so now we're at B. So basically this is a little analyzing question. Right? So once I realize everything on this basically gets shuffled, but don't mind that. So which age group is most severely affected by AIDS? Now the answer I chose was the age 20 to age 24, and I will explain why. So it says which age group is most affected by AIDS. So we have to look at the key or the legend, and it says with AIDS, the gray represents without AIDS. So since they ask which group is most affected by AIDS, we have to be looking at with AIDS, right? So if we look on this pyramid right here, the one that bulges out the most, right, is the age 20 to age 24, right? It is the one that comes out the most out of all of them. So it means that this is the centralization, or this is the gathering. This is the most prominent area, or the most prominent age group that has AIDS, right? So obviously, the way you can look at it, you see it like 80 to 84 is a small amount, small amount, small amount, and then down here it just spread off completely, right? So there's a lot of people within the age 20 to age 24 age group that has AIDS. So that is why that would be the answer, because it's spread off the most. It means that it's concentrated within this age group right here. Okay, so now the next question says, based on the data presented in figure 2, which population, male or female, has more persons suffering with AIDS in the 45 to 69 age group? So basically these questions all go for this question. So we're looking at the 45 to 69 age group, right? So which one has more persons suffering with AIDS? Let's see. So 49 to, where did it go? Oh, it's a 45 to 49. So which age group is suffering more? So if you look at this again, to me it look like the with the AIDS for females, the box look bigger over this side for females than for males. Look funny. So as you can see, I think it equal. To me, I feel like the females over here is a little bit broader, and they're suffering more from AIDS within that age group 45 to 49. That is how me interpret it. And then it says predict the socio-economic future of the population presented in figure 2, and your answer should consist of 3 predictions. So basically, socioeconomic, we're talking about how it will affect society, how these persons having AIDS, how will that affect society, affect the economy, affect business. So that's what it's talking about. So the first one, the persons themselves, so socially, the persons themselves will experience stigma from society, because obviously we know what AIDS is. So basically AIDS, it's a sexually, well, it's developed from HIV. So it started off from HIV and then it turned into AIDS, and we know that there's a stigma associated with it because of how you contract it, right? Because we know that it's an STI, right? So sexually transmitted infection. And so people will say, oh, the person is careless, them Lego, them loose, them whatever, or them run around. Right? So there is stigma associated with having AIDS. So people might kind of discriminate and against the person. So that's from a social aspect. And then the next prediction is reduction in labor, and that will slow down the economy, because if these people who have AIDS, and bear in mind we don't have any cure for AIDS, right? There's no cure. So, and we know that their immune systems are compromised also. So the fact that their immune systems are compromised, it means that they will probably get sick more. They probably won't have access to, for example, somebody might use all of their money just buy medication, and that's it, right? So, and these persons too, if the AIDS is really bad and them never did treat it, they might die. So as you can see, that would affect the economy negatively, because persons are dying from AIDS, especially if them don't seek treatment right from early. Their immune system is already compromised because of the virus, right? So because of that, their immune system is compromised. It means that it's easier for them to contract other illnesses, because somebody actually told me this. I think one healthcare worker, somebody said to me that it's the main thing with the AIDS, because even though they offer treatment for it, the main thing with it is that because it compromises the immune system. So, for example, somebody who has AIDS, if a little cold come around, it will attack them. So, the cold, the flu, any other like a virus, it can kill them, because their immune system is already so weak trying to fight off the virus, right? So, it will slow down the economy if we don't have people for work. And then the next prediction for the future is there will be a strain on the healthcare system, because if, for example, we said the age 20 to 24 age group, that was the most, they have the most, um, what should I say, the most AIDS within that range, right? So, given that if a lot of people have it, and then a lot of people have the AIDS, there's not enough treatments, and the government, it puts a strain on the government. So it puts a strain on the government, on the healthcare system, on healthcare workers, because there's not enough treatment, and there's also not enough persons to work to deliver these treatments to these patients, right? And more than likely, especially given the Caribbean, these people will be people from I guess I would say low socioeconomic background, so middle class to low. So it's not everybody is going to be able to afford the treatment, right? And so it does put a strain on the healthcare system, on the government, on the country, especially if a lot of persons keep contracting the virus, right? And it developing an AIDS. So it would be really, really bad. Alright, let's look at the next question. So, two factors that may have contributed to the reduction of the death rate. So, basically, more accessible treatment. So, if, for example, the government gives more funding to the healthcare system, or gives a special amount of funding specifically towards AIDS, then that would make people live longer, right? So it would reduce the death rates, because if somebody comes from a certain background, they cannot afford the treatment, right? So they're just going to sit with the illness, and they're just going to die. So in the case where treatment is basically, what should I say, more available, you can kind of slow it down versus you not taking any treatment at all. But basically, yes, so if there is more accessible treatment, it can help to slow down the illness. So that's one thing that can reduce the death rates, right? If they are getting treatment. And then the next thing is a better educated public. So basically, if we have, for example, different health departments, as we say, go back to the government with better funding, if their goal is to inform the public, educate the public on AIDS and HIV and AIDS, and just show them the impact of it, the risk of it, right? And even in Jamaica, that's one thing that I think the government, the health ministry really push, because they're always talking about condoms and all that stuff, right? So that's something that they're really pushing and getting tested and all that stuff in Jamaica. So that's definitely something that can reduce the death rates. Better educated public. If people know the risk, they, well, some people still agree, but some of them will, once they know the risk, they will more likely to think twice and say, listen, okay, we're not going to do this because there's STI risk and the treatment limited, or the treatment cannot save you, you can only slow it down. So people really think twice, so that can help to reduce the death rates. Alright, so now this table is talking about vitamins, whether or not they are water soluble or they are fat soluble, right? So first and foremost, this is also jumbled, but basically vitamin A is retinol, B1 is thiamine, vitamin C is ascorbic acid, and vitamin D is calciferol, right? So the first one was already done, right? So the first one is water soluble, right? So that's for vitamin A. And then we have vitamin B1, which is also water soluble, right? So basically, it being water soluble means that it is able to be like dissolved in water and absorbed into the bloodstream. If it's fat soluble, it basically means that it will be absorbed with basically dietary fat in the body, right? So we said before, vitamin A is water soluble, so that means that it can be dissolved in water and can be absorbed into the bloodstream. That's vitamin A. And B1 we say is also water soluble. Vitamin C is also water soluble, and then vitamin D is fat soluble, right? So vitamin D is fat soluble. Now let's look at the other one here. So it says name two elements that make up protein molecules other than oxygen and hydrogen. So basically the elements that make up proteins are carbon, hydrogen, oxygen, and nitrogen. So basically they said other than oxygen and hydrogen, so the other two would be carbon and nitrogen, right? So something like this in this question, this is just something that you just remember, right? You just have to remember, say, a CHON for proteins, right? So carbon, hydrogen, oxygen, and then nitrogen. So now the next question is saying state one function of protein to the human body. Now this is one definition that probably from primary school you should not forget. Don't ever forget the not even the definition, but just the function of protein. So it builds and repairs tissues in the body, right? So don't ever forget that, right? So yeah, builds and repairs tissues in the body. That's basically what proteins do. And then I think this page is going to be the last page. As we said before, things kind of get jumbled and all over the place, but yeah. So this one is saying Cameron eats a slice of pizza and drinks glass of guava juice. After this meal, which sugar is most likely to be present in his bloodstream? The answer would be fructose, right? So the answer would be fructose, and it's absorbed directly into the bloodstream. Now, part B is saying why would a slice of avocado be a better source of fatty acids than the slice of pizza? So basically, avocado contains healthy unsaturated fats compared to the saturated and the trans fats that is found in pizza. So all in all, avocado is healthier, right? And it has monounsaturated fats, which is more healthier than the saturated and the trans fat that's going to be in the pizza. But look at it, even if you never know whatever, right? Pizza is just, we can't even explain it. Pizza is not healthy regardless. So anyway, let's just go to part 3, the structure of the small intestine, maximum nutrient absorption. Identify two structures on the walls of the small intestine and how these structures facilitate maximum absorption. So the two structures we're going to look at is the plicae circularis and then the villi. So this and then it says how absorption is facilitated. So what's going on here is so the plicae circularis is basically just some large wavy like folds in the small intestines, right? So they slow the movement of digested food, allowing more time for nutrient absorption. And then villi, these are like tiny finger-like projections on the plicae circularis, and it has a network of blood capillaries and lactea that absorbs nutrients. So that's basically the two structures, plicae circularis slash large folds, and then the villi, which are tiny finger-like projections. And the next question is saying, how is it absorbed um, through the intestinal wall? That's basically what this question is saying, what is a blockage. Well, basically, facilitated diffusion. So larger molecules like fructose move through specific protein channels. So what we're doing is facilitated diffusion. And we know that with facilitated diffusion, things cannot just pass through the cell membrane. It needs help, so it has to have like a channel protein or a protein carrier. It has to be something. So this part we use a protein channel to pass through an intestinal cell membrane, and then it goes down the concentration gradient. So that's basically um, how it's absorbed through the intestinal wall. How the nutrients from Cameron's meal is absorbed through the intestinal wall. That's basically how it is. And then I think this is going to be the last section. So we're at nervous system and endocrine system. So there is a we call it endocrine system, and no, there is no endocrine system. There is the nervous system crash course. So that would really explain better the whole nervous system and all of that stuff, which the endocrine system is closely related to the nervous system. So if you know one, it's best to also know the other, because they do work hand in hand sometimes. So basically, say two activities that are controlled by the hypothalamus in the brain, and basically the hypothalamus, so it's kind of like in the middle of the brain. So basically what it does, it produces hormones that regulate heart rate, body temperature, hunger, as well as the sleep-wake cycle. So you can just choose any two in order to get the 2 marks. And then we're looking at this table, which basically we're talking about the pancreas, and we're talking about glucagon and insulin right here. So basically these are two hormones that are secreted by the pancreas, right? So they're responsible for regulating glucose levels in the blood. Now, everybody should at least be familiar with insulin, because we know about diabetes and all that stuff. So what's happening here is they are secreted at a specific response. So either when the blood sugar is high or it's low, basically. So the first hormone we're going to look at is glucagon. So basically glucagon would only be secreted, right? Glucagon would only be secreted when the sugar level is low. So when the blood sugar is low, that's when glucagon is secreted. So now glucagon is secreted when the blood sugar is low, and what it's going to do is going to convert glycogen into glucose. So basically glycogen is like a stored form of glucose, right? So it's like our bodies just kind of like just keep it. It's like this, we can't even explain it. Just know that it's like this stored what should I say, it's like a stored unusable form of glucose, right? And basically when our sugar level or blood sugar level is low, that is when the hormone glucagon is going to step in and convert that glycogen, which is stored. So it basically stored, not doing anything, and then glucagon comes along and is going to convert it into glucose, because glucose is actually what the body can use. The body cannot use glycogen, it just in the body, right? So it's like that And even once it's probably like a backup source or something like that, but it's just something that our bodies store. And glycogen, like the glycogen is going to be converted into glucose, and then the glucose will help to raise the blood sugar level, right? And then the next hormone is basically insulin, right? So naturally our bodies would produce insulin when the blood sugar is high, right? No, obviously people who have like diabetes, you know that the hormone insulin is not so, it stop being produced by the pancreas, right? So that is why they have to inject themselves or take pill, depending on the stage of diabetes that them have or the type of diabetes that them have. But basically insulin, which is a hormone, is going to be secreted when the blood sugar is high, and it's going to do the opposite, right? It's going to convert glucose, because obviously remember that glucose is sugar. Glucose is I think it's a monosaccharide. Basically it is sugar. There's no that glucose is sugar. And glucose, since we have too much of it in the blood, insulin is going to convert it to glycogen, that stored form. So it's like the body is going to like move it, relocate it, and just store it, forget it out of bloodstream basically, right? So all of this is basically just in attempt to maintain homeostasis in the body, right? So that's basically it. So that's really the action behind glucagon and insulin, right? I mean, glucagon kind of sound very similar to glycogen, because sometimes it's like a tongue twister, but two different something. So just know that glucagon converts glycogen to glucose, and then just know that insulin, just think about somebody who have diabetes. If anybody in your family have like a diabetes, you know why they might take the insulin, because the blood sugar level is too high, and you know that it can literally kill you, right? So that is why we need the insulin in order to maintain homeostasis, and then just regulate our bloodstream, right? So it's basically would convert the glucose back to that stored form of glycogen that the body does not use, and it just kind of keep it there as a backup for when you know the sugar level go low, it can draft it and convert it back to glucose if it needs to, right? So that's basically just a few pages of this past paper. That's just a few pages of it. So hopefully this was helpful. Always read the instructions, always read the instructions, with upon something. Always read it, look, pay attention to the marks that them I give, and just answer the question, right? And by the way, I may put this picture here, so that's basically it for the answers that for this past paper. So this one was done in, I think, 2016. So anyways, just everybody good luck on their exam, and hopefully everyone does well.